this problem set is on similar triangles, so I'll quickly review the ideas you need to know and remember, and then we'll go over these problems. Okay, so how are two triangles similar? Well, first of all, if their angles are matching, the measure of all three angles are matching, then they're deemed similar. Okay, so if one's a 30, 60, 90 triangle and another's a 30, 60, 90 triangle, they're similar. You can have different lengths of the sides but have the same angle. So we only say they're similar, they're not congruent. All right? Technically, you only need two angles to match to determine that the two triangles are similar. For example, if both the 30-degree angles match and both the 60-degree angles match, that's enough to determine that these two triangles are similar, because you can always do the math that the third angle is 180 minus 60 minus 30, and since the math is the same for the two triangles, the third angle is the same, and therefore they're similar. So you just need two angles. Okay? And another key idea is that the corresponding sides, meaning the side that's opposite to the same angle, so in that 30, 60, 90 triangle example, the side opposite to the 30-degree angle, if two triangles are similar, then that side is proportional. Or I should say that all the corresponding sides are proportional. For example, the ratio of the sides opposite to the 30-degree angle one is equal to the ratio of the sides opposite to the 60-degree ones. 60-degree angles, okay? So if that's not clear, hopefully these examples, these problems will clear up as I solve through them, okay? Those are the key ideas though, okay? And maybe some additional ideas that might help. The parameters are also proportional to the same scale factor, if those terms sound familiar. And the area is not, though. It's proportional to the scale factor squared. This was not on that lesson that's before this problem set, but it might be helpful to know, because I think I did a problem on that before during this series. But anyway, let's begin with number one. Hopefully, as I do some of the problems, the ideas will become more concrete if they are not too clear for you right now. Okay. As always, you should try the problems first if you're here to practice, and then come back here to see how I think through them. Okay, so you can pause the video after you see the problem. In the figure above, if AB equals 6, DE equals 3, and BD equals 12, what's the length of AE? We're interested in this length here. So how can we find that? Well, since the sections are similar triangles, let's figure out if these two triangles are similar, okay? These two angles are congruent. They tell us that right there. That's that symbol, that notation, okay? These are both 90-degree angles. So, remember I said we just need two angles to match, then these triangles are similar, okay? So these two triangles are similar by angle, angle. Right? Some books teach angle, angle, angle. Okay? So how does that help us? AB equals 6, DE equals 3. So I said the ratio of the sides are the same. So DE over AB. Okay, that's DE is opposite to this angle over here, and the matching angle in this triangle is this one. What's opposite to that? AB. So this ratio is equal to, well, we're interested in AE, so we probably want AC and CE. So this ratio of DE to AB is the same as the ratio of, in the smaller triangle, the hypotenuse is CE. Actually, we don't want that. We want to use this probably, BD, because they give that to us. So this angle corresponds to CD. So let me say CD. And this matching angle corresponds to BC. Okay? And I can write this as, well, BD is 12. So BC plus CD is BD by segment addition. Therefore, I can write CD as 12 minus BC if I really wanted to. Okay? So, how does that help me? Well, I need this in the end. So we're given this. So if I find the pieces, then maybe I can use Pythagorean theorem is what I'm thinking. Okay? So can I solve for this? I can because I know DE and AB. DE is 3, AB is 6. So 12 over BC minus 1. I can even simplify that too if I divide through by BC. So this is half actually. Let me even rewrite that. So 3 over 2 equals 12 over BC if I'm doing the algebra correctly. So this is, if I divide by 3 on both sides, that is half is 4 over BC. So BC is 2. Okay? If BC is 2, now this becomes quicker. Okay? Because I can get this side if I wanted to. How so? Well, again, this ratio, DE to AB, is the same as the ratio of DC to CB. Okay? So, 6 is twice of 3, right? So, twice of something is 2. What's that something? It's 1 then. Okay? So to get from this side to this side, multiply by 2. That's the scale factor you might have learned. And this term to this term by the same scale factor too. Because they're similar triangles, okay? And now I can get these two sides as well. I can use Pythagorean theorem. Or I could just use, let's just do it for this side first. That'll be root 10. Okay? So this side would be 2 root 10. Again, multiply by 2, the scale factor. And the ratio of the sides are all the same. So let's check one more time. 6 divided by 3, that's 2. 2 root 10 divided by root 10, that's 2. 2 divided by 1, that's 2. So this is matching what we expected from similar triangles. The ratio of the sides has to be the same. Okay? So now we're interested in AE finally. That is 3 root 10. But clearly, I don't see a matching answer. So what did I do wrong? Maybe let's start over, okay? So, ratio of these two sides is, if I go from this way to this way, it's half, or this way to this way, it's, oh sorry, this way to this way is times 2. This way to this way is times half, okay? I know that BD is 12. So BD is equal to BC plus CD. Okay, I'm going to approach it a different way because I did something wrong over here, so let's abandon that. It might be faster to just redo it completely from a different angle. Okay? And since I know that the side in this bigger triangle is twice the length of the corresponding side over here, BC is in the bigger triangle, so that is twice of CD. So BD, which we know is 12, is 2CD plus another CD, which is 3CD. So CD is equal to 4. Okay? If CD is 4, then this guy over here is 8. Okay? Because again, to get from this side to this side, times 2. Same for this, times 2. Okay? And now, therefore, this is a 3, 4, 5 triangle. That makes my life easy. So this side should be 10 over there, times 2 again. So AE is 10 plus 5, which is 15. There we go. Now I got the answer. So I don't know exactly what I did wrong there, but see if I approached it a different way. I got it. Okay, so sometimes if you get stuck, try it from a different way. Okay, this, again, a lot of times there's a lot of ways to solve these problems. In the figure above, B is congruent to D. They marked it for us. If BC is 16, CD is 10, CE is 11. What's the length of AE? Okay, so this is congruent to that. And we know these are vertical angles, so they're congruent as well. So we have similar triangles, okay? Now you got to be careful which side corresponds to or is opposite to which angle. Okay, so let's mark this as with 3 lines over here to make my life easy. Okay, so this opposite to the 3 whatever that's called is 10, and over here is 16. So 10 over 16, that's the ratio of sides, equals, now I want the one opposite to here. That's 11 over opposite to this same angle, but on this triangle is this one, which is AC. Okay. Why do I want AC? Well, I want the length of AE, that's why. Okay. So how can I solve this? Well, this, if I reduce it, it is 5 over 8, right? So am I on the right track? Yes, because it's a decimal. So AC is 11 times 8 over 5, which is 88 over 5. Okay, if we're not allowed to calculate it, which one is it? Well, this is 85 over 5 plus 3/5. Okay, 3/5 is 0.6, so I could really guess that it's C. I'm gonna double check that's the answer. And that is not, because I did not answer the question. See, I got tricked. AE is what we want. So if this is 17.6, which is not, well, actually it is, we need 17.6 plus 11, which is not even a choice. So this is a bad question. I did not even have the right choice. So if it's asking for AC, then it's 17.6. If it's actually asking for AE, it's 17.6 plus 11, which there's no choice, okay? So I didn't get tricked, per se. But always be careful. Actually answer the question. That's a common trick, though. Multiple choice. Okay. 3 and 4 refer to this following. In the figure above, DE is parallel to AC. Okay. What is the value of X? So there's actually one more theorem that says if there's a parallel line to this base of the triangle, then this parallel line intersects these two sides of the triangle proportionally as well. Okay? So this side would be proportional to that, and actually no, these two sides are proportional to these two sides, okay? I'm making lots of errors in this video. Sorry about that. Let's continue. We're gonna probably have to use that. What is the value of X? How can we get that? Well, is there any similar triangle here? Because these two lines are parallel, aren't these corresponding angles over here? That's not right angles, so let me draw it like that. And these two are also corresponding angles, are they not? And then this angle in this triangle and also this bigger triangle, right? So we have two similar triangles, actually. It is a very common setup, actually. So we're interested in the value of X, which is down here. So let's use the ratio of the sides. They have to match, right? So 12 divided by 20 has to equal 9 divided by X. Okay? And if I simplify this side, that would be what? That would be 3/5, right? So X would be 9 times 5/3, which is 15. Let me double check that's correct, since I've been making a lot of errors in this video. That's correct, okay? So we just used the proportionality. What is the value of Y? Okay, so here's where we're gonna use that theorem now, okay? As I said, actually, we don't even really have to use that theorem. So let's try to use what we have been doing so far. Okay? So 12 over 20, again, equals 7.8 over 7.8 plus y. Okay? And then we could just solve from here as well. This is again 3/5. We could solve for y. Okay, so 3/5, 7.8 plus y is 7.8. So 7.8 plus y is 7.8 times 5/3. Okay, so y is equal to 7.8 times 5/3 minus another 7.8. So this is 7.8 times 5/3 minus 1, which is 2/3. Okay, and now what is this? This is 2.6 times 2, right? Which is 5.2. The answer, let me double check again. Yes. So we didn't even have to use that theorem, okay? We could already be using what we've been doing so far. The ratio of the sides has to be the same. Of the corresponding sides has to be the same. Okay, and that's this problem set, okay? Sorry for the mistake in the beginning. Hopefully this was a good practice set though, if you needed it. And hopefully I could clarify some things if you were confused, or if this was a good review as well for you. Please like to subscribe as always if you found this helpful in any way.